Hi, and welcome to this Internet of Business webinar on IoT, connected assets, and maintaining critical infrastructure. My name is Jessica Twentyman, and I am the editor of Internet of Business. Today, I'm going to be talking to Andy Yeoman of Concirrus and Giles Price of CHS Engineering Services. By way of a brief introduction, Concirrus is a leading British player in the Internet of Things evolution. The company offers a cloud-based platform that helps organizations collect and make sense of the data that increasingly flows from a whole world of connected devices in the physical world, which use sensors and meters in order to report on their status, report on their condition, and to receive instructions remotely. So with that mission in mind, Concirrus has delivered tracking, monitoring, and control solutions to organizations across a really wide range of industries. These include security, facilities management, energy, haulage, mining. But for the purposes of today's webinar, Andy is going to be looking at a very specific case study, one that involves Concirrus customer CHS Engineering Services. So this is where Giles comes in. CHS has used Concirrus's technology and skills to create an environment that monitors airport operations in real time. The goal here is to keep critical airport systems for baggage handling, for example, for security, keep those systems up and running so that at the same time they can ensure that there's a steady and reliable and consistent flow of passengers and baggage and cargo through the airport. So on that note, I'll turn things over to Andy and to Giles so that they can take us a little deeper into this topic. Thank you, guys. Over to you.
Thank you, Jessica. This is Andy Yeoman. So by way of introduction, as Jessica said, so Concirrus is a company that's been in and around the Internet of Things for about 4 years. Most recently, we've moved away from just being a straightforward platform provider to looking specifically at how IoT and connected technologies generally can drive change in certain industries. There's a lot of talk about the Internet of Things. There's a lot of things that people are saying that the Internet of Things will be able to do. Today is going to be quite interesting because hopefully for the majority of people on the webinar, they will have actually experienced the Concirrus and CHS technology as they've come in and out of Heathrow Airport. So let me just start with the Internet of Things. So what is the Internet of Things? So in its simplest form, the Internet of Things is a series of sensors that's being deployed that allows you to learn, measure, and observe elements of the physical world. In this case, some of the assets operating in and around Heathrow Airport. What that means by observing this, what it means is that you can manage the risk and analyze the risk associated with those critical assets and their use in near real time. And by being able to do that, what that means is you can establish a closer relationship with your customer. So as it turns at Heathrow, and Giles will cover this in a moment, this is critical infrastructure. We're all painfully aware that when we go to the airport and we check our bags in, the bags go off through a little conveyor behind the check-in agent, and we have a moment where we wonder whether we're going to see that infrastructure, so see that baggage again. What actually happens behind the scenes is that bag goes through a whole series of equipment, which Giles can describe in a moment, before eventually being delivered at the gate side. And this is part of the challenge that we're looking to address, is how we improve that. So let me just hand to Giles to describe a little bit more about CHS and what he's been doing over at Heathrow and other airports.
Well, hello everybody. Thank you, Andy. CHS Engineering Service is an independent engineering service company. One of the sectors that it focuses in is aviation, and we've taken our knowledge and shared that with Concirrus and developed an Internet of Things service to Heathrow Airport that allows us to provide real-time information on critical assets and improve the uptime of critical assets at a cost that they can afford, and indeed a lower cost than would be traditionally delivered. Engineering CHS Engineering Services looks across the life cycle of assets. So we're different to most other organisations that typically would focus on design or build and construction or operate and maintain. And we take accountability through the life cycle, right from the design of assets and specification through to the operation and through to the maintenance. So the challenge with one of our key clients, Heathrow Airport, was to increase the uptime of critical assets within the airport, but at a lower cost. Now, this meant that we had to start to change our business model, and we'll talk more about that in a few minutes. So firstly, we work with the client to identify the weak spots in the operational process. And by this, I mean, if you look at the passenger experience through an international airport, it has many different sectors to it, from traveling to the airport, to checking in, to checking in your baggage, to picking your baggage up when you arrive at your final destination. And within that process are many different items of critical infrastructure that support your flight. And this includes baggage systems, and it includes explosive detection systems and X-ray systems that unfortunately have to be present in today's society due to the threats that we face and the challenges we see. So moving on to the next slide, which Andy will bring to life, which starts to demonstrate how we've combined our services to improve the customer experience.
Thank you, Giles. So just to recap, the challenge we were presented with at Heathrow Airport was summed up in sort of a pithy phrase, is that we're left under no illusion that the baggage system is critical infrastructure. I think everyone's probably aware that when Terminal 5 opened, there was a lot of adverse feedback about the baggage system failures. So we were given a specific challenge, which is that this is critical infrastructure. We cannot afford for this infrastructure to fail at any cost. And when the customer says at any cost, what they actually meant was the lowest possible cost. The specific challenge that we had was, how do we now improve the uptime of this system while simultaneously reducing the costs? The answer we came up with was remote monitoring, telemetry, and some action. We'll come through that in a moment. So the equipment that we're talking about here is a complex series of multi-vendors infrastructure. So there are, as I said earlier, when your bag goes off, it goes off through a belt, into a sorter, into some high-speed belts, goes through scanners, etc. And it's very much like a production line. One piece of equipment naturally leads to the other. The challenge is that all of the equipment is made by different vendors. So while there may be a scanner made by Siemens or L3 or Rapiscan, that scanner itself might be attached with some form of remote monitoring. If the conveyor belt that feeds that scanner fails, then the entire system fails. So now we're looking at how do we optimize that end-to-end process. And the way of doing it is to look at, well, what are the points of failure? What we found within this environment is that when failure occurs, it leaves a fingerprint. And the fingerprint it leaves is in terms of sensor input and sensor feedback. So for example, when a conveyor belt or a roller bed fails, and let's just say it's a specific roller, through a bearing failure, that bearing failure can be observed, in this case, by monitoring the vibration. So the challenge we had is, how do we do that across the entire production line when we've got all these various vendors and equipment providers involved? Again, it's true to say that the equipment in some respects is both very expensive and very mechanical. So some of the scanners that detect explosives operate using X-rays and very sophisticated computer equipment. Some of the other pieces of equipment are very mechanical in terms of roller beds and motors, etc. But what's common across them is that they're made by a variety of vendors. The other challenge that we faced that we had to solve from this was that not only were they made from a variety of vendors, but the vendors themselves who had telemetry in some of these pieces of equipment were either unwilling or unable to share that. So we were faced with a situation where we had to find a way around that. And the solution we found was to working with CHS was to deploy a constellation of sensors. And we went from our first meeting to our first deployment of sensors on that equipment within something like a 6-week period. And those sensors observed a variable number of parameters, and you can see that shown on the bottom left. We'll come back to more of that in a moment. What we also needed to do was, within the whole solution, was start to not only gather the data, but then start to observe when failures were occurring or maintenance needed to be done through the end system, and then start to correlate what were the sensory inputs that we saw when failure occurred, and can we now start to see those reoccurring? So this process was quite complex, but it's a case of ingesting all of the data. You can see this in the diagram in the middle. It's a case of ingesting the data that's coming from all these sensors in near real time, understanding that data, and understanding whether we are starting to see patterns, and are those patterns emerging again of prior failure, and then suggesting a course of action and seeing if that fixed it. So this whole concept of ingesting, digesting, and suggesting a course of action was something that could be learned. And of particular note is the parts on the top left of this slide, which is the contextual information. So one of the things that we've learned about the Internet of Things is it's a system that can't operate in isolation. You need to compare both the sensor data to some of your historic data and some of the other contextual data, whether that be machine conditions or even weather or whichever. It's the correlation of these data points to history that starts to give some of the insight. So if we can just move to the next slide, thank you. So we have the critical infrastructure. Working with CHS, we were able to identify a number of key parameters that we believed could be the precursor and the sensory inputs. So some of these are easier to measure, things like temperature, humidity, vibration, etc. And some of them were able to then understand whether parts of that infrastructure were working correctly. So we had the sensors pulling data back, say vibration, temperature, humidity, and then transforming that data into information insight. So what that means is it's not so much the data point, as it were, is that the temperature is the temperature, but it's whether the temperature is rising over a period of time and its rate of change. So broadly, this is captured into the phrase of time series data. So we're able to see, is the behavior of the device that we're monitoring changing over time? So the next element that we're going to do is, once we've got all those insights that we can see temperature changing, and we can compare that to history, we can start to predict failure. So I'll give you a specific example. By monitoring things like the input temperature and the output temperature of air from an air conditioning unit that maybe cools a computer that powers the scanner, we can see where that air conditioning unit is reducing in its efficiency. And we can then start to predict that actually after a while, it is going to be unable to cool the computer and the computer is going to shut down. So we can now see that the air conditioning unit there is likely to need some corrective action. And the decision that gets made is to then to send someone out. So we've seen data become insights, and insights become decisions, which leads us to the next point, if you're able to, which is that those decisions then become actions. So in this case, this is where technology and human intervention combine. So CHS has a team of people on site at Heathrow Airport and the airports generally. When the system observes that there looks like there's going to be a pending failure of the air conditioning unit, and we know that that system would shut down, what we're able to then to do is to dispatch somebody through the CHS system to go and rectify that. And it could be something as simple as the filters on the air conditioning unit have got clogged or whichever, but we're able to then pay attention to that. So it's the action here which starts to drive the cost efficiency. And it's the action that allows us to operate this. So we are trying to intercept failure before it occurs, and are able to do that and make those decisions in near real time. So the next slide, for those of you who had a lost youth in around spirographs, this slide may look familiar to you, but the next slide is an important challenge. As I said earlier, where we are today is that we're operating in an environment where there are multiple types of equipment from multiple vendors. We've had to deploy sensors onto machines that already have sensors. And this is very much an M2M sort of deployment at this stage. What becomes interesting when it moves into the Internet of Things is when you're able to take not only data from your own sensors, but data from other machines and other machine providers. The challenge is what becomes the point of consolidation. It's impossible for all vendors to have a relationship with all customers. That's not going to work. So there needs to be a platform in the middle that's able to synthesize that information. And that's very much the role that Concirrus is playing in here, is that the software platform needs to be able to distribute the same data to multiple providers. We can't have multiple sensors doing a similar thing. In this case, we're now working with CHS and some of our insurance opportunities, because the same data that shows whether a machine is going to fail is of interest to things like the insurers that are providing business continuity insurance, because they know that if the machine failure is being minimized, then the probability of the business disruption occurring is less, and hence the premiums for business continuity can also be reduced. So within here, this is where sharing the data truly operates as an IoT model, and again, multiple customers can win from that. So let's just go back to go back here to the platform. So we have Concirrus on the left-hand side, where we are gathering the information, driving the insight, and passing that information over to Foundations, and Foundations is then able to take action. So Giles, I don't know if you can say a little bit more about that.
Yes, well, it's the foundation system that enables us with the Concirrus platform and the Microsoft platform to actually change our operating model. So we've talked about critical infrastructure. We've talked about real-time or near real-time data. Now, we've provided a service to many airports in the past, which was, if you like, a resource-dependent service in terms of manpower. Now, we were able to use our platform to fundamentally change our business model, and at the same time offer our customers a 40% reduction in cost. So not only did they get a better service, so they went from a service of having data that was a week old to data that was more or less real time. That data was analyzed and provided them useful information. And it also provided an alerting system. So they've got real-time information with an alerting system, and they've got that for 40% less cost than they were traditional paying. I'm just going to bring some typical examples and applications, and most of which are aviation related. However, we're also applying this technology across other sectors of the market, including ports, docks, and rail. But sticking with the airport environment, there's a lot of critical infrastructure in an airport environment. A lot goes on behind the scenes to make your journey safe and timely and a pleasant experience. One of the things that we're faced with in modern day is the need to X-ray hold luggage and indeed cabin baggage as well. Now, the equipment that does that typically costs £750,000. However, the loss of that equipment will fundamentally affect the flow of baggage and passengers and aircraft from and to airports. So we've been able to take this technology and apply it to the X-ray equipment at Heathrow and to the baggage systems. And it's in place at a number of airports in the UK and abroad, and is providing a real cost saving and a better understanding of the infrastructure that they own. And this is where our expertise in design comes into play. Typically, an airport will build in redundancy, and it builds in that redundancy because it has to allow for failure. However, with better insight to the performance of that machine, you can inform design of airports and other critical infrastructure, and you can remove that redundancy. So not only do you improve the operating cost, you also improve the capital cost and overall the life cycle cost. Another example is, I'm sure we've all stood at arrivals carousels or reclaim conveyors at airports, hoping our luggage will turn up, and also waiting for that luggage to turn up. So another critical part of the process. And again, we are monitoring successfully those systems in real time. Moving just slightly away from airports, other than airports that are under major development or construction, critical infrastructure on major infrastructure projects are cranes to move equipment around the site. And we are able, again, to use the same technology to monitor, for example, bearing condition in cranes and prevent downtime on the construction sites. Passenger lifts and elevators, again, we are monitoring those. We're monitoring the bearings, the motors, the gearbox, the electrical power consumption, and providing real-time data. Going into a bit more detail, an example of what we were able to monitor. This is from a major port in the UK. You'll see to the right of the slide an image of a crane, a quayside crane, used for loading and removing containers onto ships. And we have our sensor technology installed on these cranes so that we can detect wear and tear on the bearing systems, on the wheels, on the carriage systems of those cranes. And you'll see some examples of wear and tear on some of those components on that screen. And this enables us to predict and inform the client of when we're starting to see trends that will suggest maintenance intervention is required. There are, of course, other ways of doing that, but they come with a cost, usually based with a lot of resource on site, spares and equipment on site that may not necessarily need to be there when it is there. By using our method and our approach, we can be a lot smarter in terms of how the maintenance intervention is carried out when it is carried out. I've mentioned notifications. We're able to alert our clients through the use of text messaging and emailing at predetermined thresholds that have been agreed. They may be based on manufacturer's information. They may be based on the trending information that we've analysed. They may be based on best practice or expert opinion. But we're able to set different thresholds with different levels of alert to different organisations accordingly, and ensure that a timely response is given. Real-time remote monitoring of critical infrastructure and a text emailing alerts isn't just about ports. It's not just about airports. As Andy says, it has a lot of applications across a number of sectors. And that's what we're working with now to try and deploy our product across those different sectors. So live remote monitoring, whole baggage screening, obviously key, baggage systems, parcel handling, cranes, critical infrastructure, air bridges, just a few of what we're currently monitoring. And we're in discussion to monitor other critical infrastructure. It's a very exciting time for us. Same day reporting using cost-effective and secure remote monitoring. As I say, it's enabled us to change our business model and offer our clients at least a 40% cost saving and a much, much better service. So linked with the Foundation's website, and the Foundation's Pulse application puts this in our hand of our customers and their supply chain, and means that we can provide so much more useful data and information in a timely manner and share that on a common platform. And as Andy has said, people are protective of their equipment, so we're able to provide an independent system. No matter who's producing the infrastructure itself, we can provide independent data in real time. So I'm just going to hand back to Andy that will just sort of summarize what we've discussed. So Andy.
Yeah, thank you. So the interesting thing from our perspective is that many people see the Internet of Things as a technology market and as a technology solution. But much like the Internet that sort of preceded it and allows it to occur, it's not so much the technology, it's an enabling capability. And we've seen that it is the business model that it facilitates which becomes the differentiator. That's the true advantage. And as Giles indicated, sort of a really key point to pull out here is that Giles's business has been able to successfully win and operate contracts over at the airports for 40% less than the incumbent, and still make money. Now, part of that patently is due to the talent of the individuals. Much of it is due to the fact that the technology facilitates that new way of doing business. And this has been this has been and still is a very real world example of how the Internet of Things is supporting a new way of doing business. And again, building on what we said earlier, I think we went from our first meeting to our first customer deployment at Heathrow in something like 6 weeks. Within 6 months, we were on an entire baggage line, and within 12 to 18 months, we were on every baggage line in every terminal across the whole airport, and have gone from strength to strength there. So it's a fascinating case study illustrating sort of what's going on in the wider world. And as I mentioned earlier, this same set of information is being used by the operators, the airport, to give a better level of service to their customers. It's being used by the service providers like CHS. It's being used by the insurers of this. And we are seeing this trend move through the industry, where many participants are able to take advantage of the same data. This is true in the industrial environment. It's also true in the domestic environment. We're seeing more and more proliferation of devices going into the home and to general environments, and that information will be able to be used to offer a different sort of business model. So perhaps we pause there. Jess, I don't know if you wanted to open up the floor to questions around any specific questions.
Absolutely, I'd be happy to. So yeah, if you do have questions, please enter them via the chat box. But I thought I would use the opportunity to kick things off myself. The first question I had really centers on the kind of availability and cost of tagging. We've described how sensors and meters, all this equipment has sensors and meters. It's bristling with it. But I'm wondering about tagging cargo, tagging baggage, tagging the moving objects that go through that infrastructure. Do you see an opportunity there as costs fall involved in that sort of thing, or is your main focus on the enablement of the equipment itself?
So it's a good question. There's two parts to the question. I'll answer the second part first, and perhaps I hand to Giles. Our main focus is on allowing critical infrastructure to be operated at a lower cost, and allowing other people to benefit from that, as essentially, whether they be the airport operator, consumers, insurers, etc. That's the main goal that I think everybody's striving to. Nobody wants more technology in their lives for the sake of having it. There needs to be a good, strong business reason for doing that. The cost of the tags and the equipment is absolutely coming down. There are two or three things that are going along in parallel. Is the unit cost follows Moore's law. That's declining constantly for a similar set of technology. The technology is becoming more advanced. All of the equipment is bristling with sensors, but as we mentioned earlier, we can't get to some of that sensor data. But in the midterm, procurement takes care of that. So you'll start to see, I can't speak on behalf of any of the airport operators, but if I were them, I would be putting into my tender that I would like you to provide equipment, and part of the condition of supply is you make your sensor data available. So that then means more data becomes available at almost a zero cost, because it's then on board. But the big innovation is around business model, and I think, Giles, I mean, perhaps you can just detail it again. You've come from your contracts. You've come from having no connected contracts to a significant business in connected contracts. I don't know if you can talk about that at all.
Yes, absolutely, Andy. As I say, the business model we've been able to adjust. So very much a manpower-based resource model, going to site, collecting, downloading data, bringing that data back, analyzing the data, producing information and communicating that back to the client. However efficient you are, that takes time, and that typically took 4 to 7 days to complete that activity. And that meant sending people out in vehicles to site. It meant them going into secure areas, and all the challenges that that presents, and the cost that that effectively presents as well. So by being Internet of Technology based, we've been able to remove all of that overhead, and therefore, as I say, typically make us, not only offer a better service, but reduce costs by 40%. What I would just add to what Andy has said, and the other part of the question, is whilst our focus at the moment is on infrastructure, generally critical time-based equipment, be it airports or elsewhere, I see airports changing their operating model as well as the technology allows and the cost of technology reduces. And perhaps airport operators won't build as much infrastructure. Perhaps they'll just buy a service, an end-to-end service. And that service could be provided by an entity that is actually tracking the passenger and the bag throughout the journey. So at the moment, we're probably relatively familiar now in the last sort of 5 years or so with checking in online. And I think people will start to become more familiar with checking their baggage in online. The next step will be to know where you and your bag are at any second. Unfortunately, at the moment, you may not know if your bag's arriving until you get off the aircraft and hopefully collect it. And that's known as the misconnect rate. My previous experience in aviation at times, where if you were a transferring passenger, you could expect to have a misconnect rate of 30%. So 30% of transferring passengers on that aircraft that you were sitting next to were not going to get their bag. Now, we wouldn't want, to continue with that type of trend. And I think that the use of technology will mean that we'll be tracking using our RFID and other devices as they become more cost effective, the end-to-end process throughout aviation and beyond.
Actually, that's a really good point, because this comes down to differentiation at the consumer level. Because if a given airport were to deploy that sort of baggage tracking system, so you can imagine a scenario where I've got on the aircraft and I know that my bag's on as well, because the infrastructure has told me that my bag is on the aircraft. What would be interesting there is that the airport differentiates by having a better service. So as a consumer, you go, actually, I like traveling through airport X because I know that my bags are there. And it's that certainty which provides a differentiator for the airport in terms of service.
Great, fantastic, guys. I've actually noticed we've got a couple of questions coming in, and I want to, give you the chance to address those, because these are the issues that our participants are most interested in. The first question is from an Arzul Raz. Arzul comes from a networking background, so is kind of most focused on the glue, I guess, holding all this together. So the question is from Arzul: did you work closely with kind of networking providers like Cisco on this project for this implementation? And if yes, kind of how important is the role sort of from the tech vendor side in supporting this and bringing all the plumbing together, I guess?
Yes, so it's a good question. Plumbing, we've learned a lot about plumbing in terms of the technology here. So one of the questions, we did not work with Cisco, and we did not work with any of the equivalent providers to Cisco. We took the decision that in order for this to be quickly and swiftly deployable, we actually needed to create an alternate infrastructure. So we used wireless communications. So everything that's deployed in this environment operates on wireless comms with some local mesh networking, backhauled via a private APN through the wireless carrier, so the telco network. So at one level, it was incredibly complex making sure that works. Remember, we are operating in an airport environment where there's a high degree of security involved, and getting onto those networks would add months, if not potentially years, of delay into a project like this. Now, that on one level simplifies the issue of communications. On another level, it makes it more complex because the equipment and the nature of the equipment that we're trying to monitor tends not to be in open sky. So some of this equipment is at the bottom of basements surrounded by lots and lots of metal equipment, which tends not to be overly compatible with communication sometimes. So we have to be cognizant of that. So we've used a whole variety of meshing technologies and wireless and comms technologies to make that work. And that was very much some of the expertise that Concirrus brought to the table to basically allow to get that data back in near real time that allowed then CHS to make the business critical decisions on it.
Fantastic. Thank you for that, Andy. Another question has come in from Brenton Salati. Brenton's very focused on the kind of the makeup of your average sensor. So Brenton wants to know, how does a sensor work in this ecosystem? What does it cost? What's its battery life like? How is it operating with kind of networking protocols? And what data can it and does it report, and at what frequency? So kind of the anatomy of today's most modern sensors.
Okay, so I'm trying to think about a good answer to that. So I think this is a very pragmatic answer. So there is no such thing as an average sensor. What we found is that the sensors that we need are very specific to the task in hand. So if you look, for example, at vibration and trying to detect bearing failure in a roller bed, you need a system which is very sensitive to a particular range and frequency and harmonics of vibration. And I think this is where us as companies between Concirrus and CHS have worked really well together. CHS's expertise is understanding the mechanical elements of this equipment and how it operates. It's come from, I'm looking at Giles, it comes from like 20 years of experience of understanding what that is. So part of the challenge that we solved collectively was, well, what is the right specification for a sensor? What does it need to do? And the learning part for us was vibration. It took a lot of work. We engaged some independent studies. We had some university work done on it to actually work out, well, how do we measure vibration and what would that mean? And then the next challenge was, okay, given that that's the specification, how do we find that and then make it work within the price point? And in some cases, make it work in what is a very harsh environment where you can't have it cabled, it needs to be wireless, there's no source of power, etc. And yet that sensor can't have batteries that need to be changed every hour, etc. So that very much was the specifications of that, and those sensors are very much, if you like, the secret sauce of how this has been made to work, combining it with the expertise that CHS is bringing. I don't know, Giles, want to talk about the work you did there?
It's a very good question, and to a degree, we're still learning, and we're also discussing with our clients on a continued basis. New needs that they have, different ideas that we have, and therefore that requires us to be right at the edge of understanding what sensors are available, what different dynamics do they bring, and we work with a number of different sensor companies, and we effectively want more of a plug and play solution, so it can be bespoke to certain customer needs. But so far, I mean, the focus has been on vibration, humidity, and temperature. And a number of different applications. Different machines may need a number of different vibration sensors. They may need a number of temperature or humidity sensors. It depends on the complexity of the equipment. But there are ranges that we have to operate within, and we're continuously developing the product to be smarter and smarter. And the cost of sensors is also coming down. So again, that opens up our different options. And that means we can offer different levels of services to different customers as and when they need it.
Fantastic, that's great. So another question's come in, and it really looks at insurance. This is a question from Matt Kelly, and Matt wants to know, what is the feedback loop with insurance companies in terms of this creating better insight into risk? how does equipment breakdown and business interruption affect insurance? Is there an aspect here of this kind of scenario in the implementation that has been done?
So, and again, so there absolutely is implications for insurance, and we're at the early days of this. So if we take a couple of different examples, if I may, at the very top level, airports are very complex environments, lots of equipment, lots of parties, and actually Giles alluded to it. The airport themselves are a very big landlord. They build a building, operate a space, etc. But actually, all the services within it are operated by third parties. So as it comes to insurance, there are a couple of things in terms of the infrastructure itself and how it's operated. That sort of thing is insurance like business continuity and disaster recovery. So if there's a fire, if there is an incident, can we get on top of it? Can we cover a catastrophic loss? Obviously, the fact that let's take an example. If there was a catastrophic failure and a catastrophic loss, whilst it would be covered from insurance, the actual operator themselves doesn't want the facility to be out of action. Being compensated for the loss of equipment or loss of facility doesn't compensate them for their losses of revenues. In terms of, go to the other end, in terms of consumer and travel insurance, well, today the policies aren't written that way, but you can imagine a scenario where the insurer may say to you, well, actually, I'm going to write you a very specific insurance policy where you say, I'm going to be traveling through Heathrow Airport onto Chicago, and then I'm taking a holiday in San Francisco, whichever. And you get one price, whereas if you say, actually, what I'm doing is I'm going through Gatwick and I'm going to Nairobi, you may get a different price because the chances of loss is the same. And that granularity of risk in the data gives you a very personalized product. So it's still very much early days, but what we do know is that the insurers have a very strong interest in customizing their products and learning on the back of the data that's being created. Again, Giles, you came from the airport itself. I don't know if you...
Yes, I mean, the loss perhaps of a day's operation at a major airport could be circa sort of £1 million a day just in operational cost. I spent many a time with the big corporate insurers coming into airports to understand how well they're being operated, how well they're being maintained. And obviously, if you could demonstrate that you were maintaining and operating your airport in the most efficient way and add an element of safeguarding and robustness in what you were doing, obviously the insurers looked on you favourably. Equally, if you couldn't demonstrate that you were looking after the equipment appropriately and you were having breakdowns and having failures, or there was concern with life safety systems, obviously they take a slightly different view, and in very simple terms, your policy goes up.
Fantastic. That's great, guys. I'm conscious of time passing very quickly now. So I wanted to invite participants, if you have any further questions, the email to which to send them has been displayed, and we will try and get those to Giles and Andy and get responses for you. Giles, Andy, I wanted to turn to you and just say, is there anything you wanted to add in a sort of summing up, as it were?
I think from my perspective, we encourage people to start. What we know about this system that we have today is it was part of a journey that took us 2 years to get to the stage we're at. It's proven to be very successful. It's now business critical. Everyone's earning some money of it. This is a new way of operating. It's a new business model, and we encourage people to start because most of the value that we've got out of it has come out of learning from experience. So small steps.
Fantastic. And Giles, I just wanted to sort of ask you, I'm sure that rings true for you. How much of this was a kind of a leap of the imagination, sort of an exploration of the art of the possible for your company?
Well, absolutely, it was. I would say on the safe side, we're a team of engineers by background, from a number of different sectors. So the first principles of what we were trying to do, that wasn't a leap of faith. We knew that it's good practice to understand how things are operating, and if you understand how they're operating, you can intervene in a timely, cost-effective manner. The last thing you want as an airport operator or maintainer is failures, unpredicted failures that impact your operation. Leap of faith, yes, to a degree it was, but I think with the background and the sound foundation of first principles, and seeing what was happening in the technology markets and the art of what was possible, and more importantly, what was possible in a cost-effective way at a lower cost. Some of what we talked about, of course, could have been done 10 years ago, but it couldn't have been carried out because of the costs associated. So once you understand that side of the model, and how cost is only going to come down as technology improves and improves, you get a better and a better business model. And it makes absolutely sense. I get sense to us, I guess the biggest frustration is, it does take time to perhaps bring people around and inform people and demonstrate what is capable these days of being done.
Fantastic. That's a great note and really positive note to end today's webinar on. So thank you very much, Giles, for kind of telling us the story of how CHS Engineering Services has got involved here. And thank you, Andy, for explaining the role that Concirrus has played in getting them to where they are today. And thank you to all our participants as well for joining. I hope you've enjoyed the webinar, and look forward to seeing you again on the next one. Thank you very much.